We are given two functions, fx and gx. Fx is a quadratic that is defined for x less than or equals to -1. Gx is a linear function defined for x greater than or equals to -1. Part A, we need to express fx in the form of x plus a squared plus b and to state the range of x. So in this form, we have x plus a squared plus b. This is what we call the vertex form of a quadratic. And in order to do that, we have to complete the square. So fx is x squared plus 2x plus 3. And to complete the square, we have fx plus 2. We have fx plus 2x. And then we need to add the square of a number and subtract the square of that same number. So in effect, we are not changing anything. And that number is half of the coefficient of x. So half of 2 is 1 here. These first three terms is a perfect square trinomial, and we can factor that to be the square of x plus 1. Then we have minus the square of 1, which is 1 plus 3, and that gives us x plus 1 squared plus 2. So we have it in the vertex form already, and we need to state the range of f. Fx is a quadratic that opens up. So we have a graph like that, and that vertex. So we grab x plus 1, set it to 0. When we set that to 0, x is -1. Then this vertex has coordinates -1 and 2. So the y coordinate is 2. And since x is less than or equals to -1, then the branch that we want is actually this part. This is the branch that we want. We ignore the other one. And we can see that the y value for this branch, right? X is less than or equals to -1. Y is greater than or equals to 2. The y values will give us the range of f. Therefore, the range of f is any real number that is greater than or equals to 2. Part B, we need to find an expression for f inverse. It is easier to use the vertex form of fx. So instead of writing fx, we let y to be the square of x plus 1 plus 2. And to find the inverse of a function, we interchange the x and y, so that y becomes an x, and that x becomes a y. Now we just need to isolate y. So we can flip this over, and y plus 1 squared plus 2 equals x. Move the 2 over, y plus 1 squared is x minus 2. And we need to take square root now to eliminate the exponent. Y plus 1 is plus minus square root of x minus 2. For intermediate steps, you must make sure that you have a plus minus here. And we figure out which one we use later. Then move the plus 1 over. We have plus minus square root of x minus 2 minus 1. Basically, for this thing, if you look at this y here, there are two parts to this. One is negative square root of x minus 2 minus 1, and the other one is square root of x minus 2 minus 1. So for an inverse function to exist, we have to just pick one of these. Which one is the inverse of fx? To determine the inverse of this function, let's look at this case here. For fx, x is less than or equals to -1, and y is greater than or equals to 2. For the inverse, you have to interchange the x and y. Therefore, for the inverse of a function, instead of x less than or equals -1, we have y less than or equals to -1 and x greater than or equals to 2 for an inverse function. Now we need to see y less than or equals to -1. This will give us y value that is less than or equals to -1. Yeah, -1 minus a positive number. So the y value must be less than or equals to -1. For this thing, you have -1 plus a positive number. So your y would be greater than or equals to -1. Yeah, we just forget that. The inverse of fx is negative square root of x minus 2 minus 1. That gives us the inverse. Make sure you pick the correct branch. Part C, we need to solve the equation g of fx equals 13. This is a composite function g of fx, meaning that you replace the x in g by fx. And fx is x squared plus 2x plus 3. This equals 13. So for this case here, g of fx equals 13. Then we find the g of this function. We know that g of x is 2x plus 1. So g of x squared plus 2x plus 3, we need to replace this x with all that. Then we have 2x squared plus 2x plus 3, and then we still have a plus 1 in gx. That equals 13. Bring the 1 over. We have 2x squared plus 2x plus 3 equals 12 here. We can divide throughout by 2 so that this 2 is gone. X squared plus 2x plus 3 equals 6. Now move the 6 over to the left. We have x squared plus 2x minus 3 equals 0. We can factor to get x plus 3, x minus 1 equals 0. Solving for x, we have x plus 3 equals 0 or x minus 1 equals 0. So either x is minus 3 or x is 1. Now we have to be careful with this case here. The domain of the composite function refers to the domain of f here most of the time. So for this case, for f, x must be less than or equals to -1. So that is the greatest domain of g of fx, if we ignore everything else. Since x must be less than or equals to -1, because that would be the domain of g of fx, the only solution is x equals -3. X equals 1 is not in the solution set because of the restriction in the domain of f.